Welcome back. In this class, the first thing we are going to learn is how to convert terminating and non-terminating repeating decimals into fractions. So let us start. Now, first two decimals which I have taken is terminating decimal. It's 0.61, 0.0028. And these are non-terminating repeating decimal. Now let's start with the terminating decimal. The first one is 0.61. What do we do is just write the whole number, whatever it is. It's 61. So here just write 61 without the decimal. Then you see after decimal, you count how many places are there. Here we have 1, 2. So put 2 zeros and 1. Now you cancel if possible. If here we cannot cancel, so we'll leave it. Then if you take the second one, we have 0.0028. So if you write only the number here, it's only 28. So we'll write 28. Without looking at the decimal, it's 28. So 28 divided by, now count after the decimal. So 1, 2, 3, 4. So we have 4. So we'll put 4 zeros and 1. Now we can cancel, in this case, to even numbers. So we can cancel here. 2 14. Now 2 5s are 10 and 3 zeros. Then 2 7s are 14. 2 2s are 4. 2 5, 2 0, 2 0. So we have 7 by 2500. Now if you say another one, if I take, say if I have 1.2, how to convert? So it will be 12. This is whole number is 12 by how many years after decimal? How many place? One place will be 10. 12 by 10. Then you cancel to 6 to 5. So 6 by 5 will be the fraction. Now let's look at the non-terminating repeating decimal. So this one, the third one, your 1.2 bar. What does it mean? It means 1.2 will keep on repeating. Okay. So what we'll do is we will represent this number by x. Let x equals to 1.2 bar, or you can write 1.2 into 2 into 2. Let it be equation 1. Now in this type of sums, if it's only one number repeating, here 2, only one digit which is repeating, that is 2. So if one digit repeats, we will multiply both sides by 10. So here we'll multiply by 10. So you're writing 10x. So if you multiply here with 10, the decimal will shift by one place. When you multiply by 10, decimal shifts by one place to the right. You multiply by 100, it will shift by 2 places, 1,000, 3 places, and so on. So here we are multiplying by 10. Since we multiplied here by 10, here also will multiply by 10. So the decimal will come here and will be this 2's. There are many 2's. We can write as many as we like. So this is equation 2. Here what we did is multiplying both sides by 10. By 10. Multiplying both sides. You can write the multiplying both sides by 10. Okay. Now why 10? Remember, if you have one number repeating, you will multiply by 10. If in this second case, you have two numbers, you will multiply by 100. If three numbers, you will multiply by 1000, and so on. Now, after getting this two equation, we just need to subtract this. So we will write subtracting the first equation, equation 1 from equation 2. Let's write equation 2 on top. 10x equals to 12.222. There are many 2's, so this is our equation 2. And we will write this equation 1 below. 1.222 and so on, equation 1. So we are subtracting this. Subtracting means we'll change the sign here. So 10x minus, this is 10x, and here no number means it's 1. So 10 minus 1 is 9x. And here if you subtract this one, this side will be all zeros, so no need to write, after point will be all zeros. So 12 minus 1 will be 11. 11.00000. So we don't have to write 0.000. So we are left only with 11. So next line, x will be equal to 11 by 9. We cannot cancel anymore. So what was x? We took this number as x. Therefore, we can say 1.2 bar. That is x is equals to 11 by 9. Okay, let's look at the next one, 0.37. Here two digits are repeating. In the previous one, it was only one digit repeating. So here 0.37 is same as 0.373737 repeating as many as, right? So we'll denote this by x. So we'll take it to be x. So x equals to this one. We'll write it as equation 1. Now since two digits are repeating, we'll multiply both sides by 100. Remember, when one digit repeats, we'll multiply by 10. Two digits by 100. Three digits by 1000. So when here 2 digits are repeating, that's why you are multiplying by 100. So here it was 1, so you multiply by 100. And this side, when you multiply by 100, remember the decimal will shift by 2 places. So the decimal was here, it came there. So we got 37.3737. This 37 is keeping on repeating, so we can write as many times as we like. So here we have written multiplying both sides. Now what we have to do, we just have to subtract this from equation 1 from 2. We'll write equation 2 on top, equation 1 below, and subtract. 100 minus, if there is no number here, we'll take it as 1. 100 minus 1 is 99. And 37 minus 0 is 37. And this side, it's all 0.000. 0. We'll get all zeros, which we need not write. So next, x equals to, this x equals to 37. This 99 will come down. We cannot cancel, so 0.37 bar equals to 37 by 99. Okay, the next one is 0.547. Now you see the 5 is not repeating, only 47. This one you can write it like this, 0.5. Only 47 is repeating. So 47, 47, 47. Okay, so let's denote this by x. So 0.5, then 47, 47, 47. This is as equation 1. Now, in this type of sums, remember, you try to, first step is take the decimal before the bar. The bar is still here, so before bar means before the bar number. So we'll try to bring it here. Remember, before the bar number. The bar number starts from here, so we'll try to bring the decimal here. Okay, so if you want to bring it here, how many places? We have 1 place. So we will multiply both sides by 10. So in the next line, means you multiply by 10 here. Here the decimal will just shift by 1 place. So we will write 5.47, 47, 47, and so on, equation 2. So you can write multiplying both sides by 10. Okay. Now, first step, remember to bring the decimal before the bar number. And then this next step, we'll make another equation. It should go after the bar. So bar is still here. So before the bar number, we'll try to put first. So 1 place. Now it is going from here. We need to shift it till there. So we will multiply equation 1. How many places now? Count. 1, 2, 3 places. 3 places means 1000. So 1000x. So we are multiplying actually equation 1. Equation 1 by 1000. So we look at 1, not here. We look at here. From here, first 10. So it went there. So now 1000. So it will go 3 places. So count 1, 2, 3. So it will go there now. So if it goes there, so it will be 5, 4, 7. Then we have lots of 4 sevens, 4 sevens, 4 sevens. Equation 3. So here we are multiplying equation 1 by 1000. Okay, here we multiply by 10 because we wanted the decimal to come here. After that 1000. Now we will subtract this 2. We will subtract equation 2 from subtracting equation 2 from 3. We will not subtract 1, remember. In this type, we will make 3 equations, we will subtract this 2. So let's write this equation 3, which is 1000x equals to 547.474747. This is our equation 3. And we have equation 2, 10x equals to 5 here. So 474747 equation 2. This was equation 2. And then subtract the 0 here. 100 minus 1 is 9 here. And this will be also 9. So we have 990. And if you subtract this, 7 minus 5 is 2. So here it's 4, 5. And this side will be all zeros after decimals, which we don't have to write. Okay. Oh, x I have not written. So x will be equals to 542 by 990. After that, we just have to cancel. You can cancel by 2. 2 2s are 4, 2 7s are 14, 2 1. Then you can cancel this by 2 4s are 8, then 2 9s are 18, 2 5s are 10. So you cannot cancel anymore, so leave it like this. Therefore, you can write 0.547 bar is 271 by 495. Let's take one more of this type. Let's do one more of this type, where this one. Here you see only 3 is repeating. This other decimal places are not repeating. These numbers are not repeating. So we can write this as 0.012, and then till here it's not repeating, and then 3 starts repeating. So we are denoting this by X. Now you remember the steps. So first step, you have to go before the bar number. This is the bar number here. So we have to shift the decimal till here. So how many places you can count here? 1, 2, 3. So 1, 2, 3 means 1000, 3 zeros. So we are multiplying this equation 1 by 1000. So if you multiply by 1000, you shift it here like this. First count 1, 2, 3. So it will come here. So it's 0.1. The decimal will come till there. It will be 0.12. 0.12 it's 12. 0.12 is 12. So 12.333 will remain. Now next step, first step will come before, and then we'll go after the bar. Now again count from the beginning, from here. 1, 2, 3, 4 places. So we need to go 4 places. 4 places means 4 zeros. 4 zeros. 1, 2, 3, 4 zeros. 10,000. So you're multiplying equation 1 by 10,000. Now you're going 4 places. So 4 places. See, from here 4 places. 1, 2, 3, 4. So you'll go till here. 1, 2, 3, 4. 4 places. So it's 0, 1, 2, 3. So you'll write only 1, 2, 3, 0. We don't have to write. So and then 3, 3, 3, 3. So here we have written multiplying equation 1 by 10,000 here. Equation 1 again by 10,000. Now next step is just to subtract these two equations. So we are subtracting. When you subtract, you will get here 9,000. Here 1, 1, 1. So this is our answer. Oh, here we can cancel because 1 plus 1 plus 1 is 3. This is divisible by 3. And 3 is a 9. 3 7s are 21. Then here 3 3s are 9. 3 0, 3 0, 3 0. You cannot divide anymore. So 37 by 3000. Now, if this is one method, but if you sit for any competitive exams, making such a long method, it will be just waste of time. We can do this type of sums in just 1-2 seconds if you know the shortcut method. I'll show you the shortcut method now. Now, let's see how can we do this type of numbers, not terminating, repeating decimals, expressing in the form of P by Q by a very shortcut method. Especially in competitive exams, if you're sitting for competitive exams, if you have to write let x equals to this and then making a long answer, you will not get time to complete the paper on time. So the shortcut method, I have written the rule here. See the rule. Write the whole number. Say for example this one. What is the whole number here? 0.3. Without looking at this, well, it's just 3. Minus the number before bar. Here before bar there is no number, so it's just 0. We can write 0. And below I have written put 9 for each bar number. Suppose you have 1 bar number, you put 1 9. If there are 2 bar numbers, say in this case we have 2 bar numbers, we put 2 9s. 3 bar numbers, we put 3 9s. And 0 for others of the decimal. So we have only 1 bar number, so we'll put 1 9. And we don't have any other number after decimal. If there was any other number here, we would put 0, but there is no other number. So this is just 3 by 9. You can cancel. 3 1s are 3, 3 3s are 9. If you look at this one, it will be, if you write the whole number, the whole number is 12. If you minus the number before bar, all the numbers before the bar, don't look at the decimal. Before the bar it's 1, so just subtract 1. Now below, put 9 for each bar number. Again, we have only 1 bar number, so 1 9. And 0 for others after decimal. Others after decimal, we don't have any more number, so we don't have to write 0. So this will be 11 by 9. Then if you look at this one, it's the whole number is 12. This will be 12. Without looking at the decimal, the whole number is 12. Minus the number before bar. There is no number before bar, so we don't have to subtract any number. And how many bar numbers? Put below, that's the denominator here. Put 9 for each bar numbers. We have 2 bar numbers here, 1, 2. So for 1 bar number, we'll put 1 9. There is another bar number, so we'll put 2 digits, so 2 9s. 3 digits, we'll put 3 9s. Then you can cancel and get the answer. If you look at this one, this will be equal to, again, follow the rule. This is 0.123, right? The whole number, it's 123. 0.123, it's 123. Now, minus the number before the bar. So before bar, this is the bar. Before the bar, this is the number, 0.12, which is 12 only. So without looking at the decimal, this is 12. Now, put 9 for each bar number. How many bar numbers? We have only one digit under bar. So we'll put only 1 9. If there are 2 digit under bar, we'll put 2 9s. 1 and 0 for others after decimals. Now for these two numbers after decimal, we have 2 more digits, 1, 2. For them, we will put zeros. For this 2, we'll put zeros. For this one, we're putting a 9. And for this 2, after the decimal, we're putting zeros. Then you'll subtract and you'll get the answer. Now let's learn how to add or subtract irrational numbers or radicals. Now I've written down a rule here. When we add or subtract, we only add the coefficients or the numbers which are outside. Like here, this is inside and this is outside. We will be adding only for like radicals. Now what do you mean by like radicals? Supposing you have 2 root 3. If you have another, say 5 root 3. If this is same, then these are called like radicals. And this will be added or subtracted depending on the outside. Let's do this sum. Now here we have root 3. And here also we have one more root 3. So they are like. So let's arrange them. Root 3 plus 2 root 3. Then we have plus 2 root 2 minus 5 root 2. Now these are like radicals. And these two are also like. These are root 2 root 2. These two are root 3 root 3. So we'll add only the numbers outside. So what is the number outside? If you don't have anything, take it as 1. So it's plus. So plus 1 plus 2 will be plus 3. And root 3 will remain root 3. Don't add this. Like when we add 3x plus 2x, we add only the coefficients, this 3 plus 2, 5x. We don't add x plus x. We don't add this number. So similarly, we don't add this. Don't write 3 plus 3, 6 will be wrong. Now similarly here, this side, both are root 2. One is plus 2, another one is minus. Since the sign is different, one plus, another minus, we'll subtract. And we'll put the sign of the greater. Here the greater number is 5. So we'll put minus. And 5 minus 2 is 3. And we will write root 2. Say here plus and minus. Minus we have to subtract. Minus is bigger, so minus sign. And 5 minus 2 is 3. And we don't have to do anything. Now we cannot do anything anymore. This will be our answer because these are unlike radicals. Root 3 and root 2 are not same. Let's take another question. Say we have root 12 plus root 27 minus root 75. Now when you look at this numbers inside, you may think they are unlike radicals. But if you have big numbers inside, what you have to do first is simplify them. Simplify or factorize this. 12. 12 will be 2, 6, 2, 3. So we're getting 2 squares. So this is a square root. So we'll get 2 squared into 3. Similarly, if we break 27, we get 3, 9, 3, 3. So we have 3. It's a square root, so we'll collect the squares. So 3 square. We'll put 3 square into 3 minus 75. If you break this one, we have 5, 25. Oh, sorry, 5 ones are 5, 5 fives are 25, and 5, 3. So we have 5 square here. So we have 5 square into 3. Now, this number has a square, and we know square and square root cancels. So this 2 can come out. But this square 3 doesn't have a square to cancel the square root, so it will remain inside. This square and square root will cancel, so this 3 can come out, and this 3 will remain inside. Here, this square and square root will cancel, so 5 will come out, 3 will be inside. Now, first line when you see they looked unlike radicals, but after simplifying, you see all of them are root 3. So what we are learning from this sum, if you have a big number, we should always simplify like this and then see what is the number inside the root. Now all of them are root 3, so we can add or subtract the coefficients, the numbers in front. So what do you have here? 2 plus 3 is 5 root 3, and this minus 5 root 3. And 5 minus 5 is 0. 0 root 3, we don't have to write root 3, 0 is 0 only. Learn how to multiply or divide the radicals. Now when you multiply, remember I have written it down, both outside and inside numbers, okay? That means first we will multiply outside numbers. These are the coefficients. So first we'll multiply 4 into 2, 8. And this, then inside numbers. Inside we have this root 3 into another, this 3. So, but 3 into 3 will become 3 square. So square and square root will cancel. This will be 8 into 3, 24. Let's take one more number, one multiplication. Let's say we have 3 root 28 into 2 root 7. So they are unlike, still we can multiply. So we'll just multiply 3 into 2 outside. Inside 28 into 7. But 28, 3 into 2 is 6. This 28 and 7, before multiplying, you check first by factorizing. 2, 14, 2, 7, and we have a 7 there. So we have 2 square, and this 7 here, and that 7, 2 7, so it will become 7 square. So that's why you should not multiply before. You should check by factorizing and see whether you can make it into squares. So this square and square root will cancel, this will come out. Since square and square root will cancel, this 7 also will come out. Now 6 2s are 12, 12 into 7 is 84. Let's see one division. Say let's take 16 root 6, divide, and say 4 root 2. You can take any value. Again, for division also same rule like multiplication. You divide the numbers outside. The numbers outside are 16 and here it's 4. We'll divide outside with outside. And then we will write down the square root once, and we have 6 inside here and we have 2. So we'll divide inside. Outside with outside, inside with inside. So 4 1s are 4, 4 4s are 16, 2 1s are 2, 2 3s are 6. So you're left with 4 and inside root 3. So this will be the answer. Remember, for multiplication, we don't have to worry whether it's like or unlike. We'll multiply outside and inside. But if it is addition or subtraction, we have to remember it should be like and add only outside, or subtract outside only, not inside. Now let's look at this question. We have to simplify 5 plus root 3 and 5 minus root 3. So we are multiplying here. So we have this numbers are in the form of a plus b in a minus b. 1 plus and 1 minus, and the numbers are same. So we know it's a square minus b square formula. So it will be a square, that is 5 square, minus b square. A plus b, a minus b is a square minus b square. And 5 square is 25 minus root 3 square. Square and square root will cancel. So this will be 3. This will be equal to 22. If you look at this question, root 3 plus root 2, again root 3 plus 2. We are multiplying the same thing twice. So when you multiply the same thing twice, we say whole thing square. Now, a plus b whole thing square formula. What is a plus b whole thing square? A square, the first one square, plus 2a. A is root 3. Into b. What is b? B is root 2. Plus b square. B means root 2 here, so root 2 square. So square and square root will cancel. This will become 3. And here we need to multiply. How do we multiply? Outside number with outside. This is outside and nothing else. So we just have 2 outside. And inside we have 2 and 3. Inside root 3 and root 2. 3 into 2 will be 6. Plus this root 2 square will be 2. Now we cannot add this 2, but we can add this 2 rational numbers. This 3 and 2. This 3 and 2 will make 5. And plus 2 root 6. And this will be our answer because we cannot add this 2. So that's the answer. Let us look at this question. Prove that root 3 plus root 5 is an irrational number. Now this type of sums is done in a little different way. What we do initially is, we are asked to prove irrational. We will consider, or we'll assume it to be irrational. We'll assume to be irrational. And at the end, what will happen? Our assumption that it is rational will be wrong, so it will become irrational. Let's see how to do it. So first we will denote this by x, and we will consider it to be rational. Remember, we have to prove irrational, but we are considering rational. Now next slide, we are just squaring both sides. On squaring, we know the formula of a plus b whole thing square. So a square plus 2ab plus b square. So x square, root 3 square becomes 3. Square and square root will cancel. This 2 is here. Inside will multiply. 3 into 5 is 15. And root 5 square is 5. Next line, x square. This 3 and 5 will make 8. Okay. Then we will bring this 8 to the left hand side. So x square minus 8 equals to 2 root 15. So next line, this 2 also will bring. So x square minus 8 by 2 equals to root 15. Basically what we do here is we will separate all the rationals to one side. Okay. And irrational in another side. Okay. So looking at this side now. See, remember x, we took it to be rational. So x is rational. So we know if we square any rational, it will remain rational. So x square is rational. So this is rational. And 8 is already rational number. 2 is also rational number. That means this whole part is rational number. if x is rational. Now in the right hand side, if these are equal, now we are saying these are equal. So if this is rational, this also should be rational. So if this is rational, we have to tell that root 15 also rational from equation 1. But we already know that any root number has to be rational. So that means what we are getting, x square minus 8 by 2 equals to root 15, it's not correct because a rational cannot be equal to irrational. So if I consider x to be rational, then this what we got is not true. It's not true if x is rational. It will be true if x is rational. It's not true. That means our assumption that x is rational is wrong. So if x is rational is wrong, that means x is irrational. And what is x? X is root 3 plus root 5. So if x is irrational, root 3 plus root 5 is irrational. Okay, let's stop for now. In my next class, I will be teaching how to rationalize the denominator, which is a very important topic. And we will also look at sums based on exponents. Thank you, and we'll see you in the next video.